Hmm. All right, I'm seeing Brittany and Isabella, otherwise known as Ella, Allison, and Sylvia, but I'm not seeing pictures yet. Got not much audio, not much video this morning. There we go. There we go. Okay. All right, got Jessica. Sylvia's always front and center here. I don't know why that happens, but it always does. Nice smiley face on a Monday morning. Okay, let's see what I got here. Here we go. Okay. So, how's it going, guys? This is the 5th week of this, like the longest 4 weeks of my life. Seems like a long time. We're still managing, and we only have 2 weeks left. I guess that's good news. I'm not sure. Okay. So how's everybody doing? It's hard for me to tell anything at this point. So Jessica, I can't see you, but how are you doing? Unmic if you can hear me.
I'm doing good.
Okay. All right. How are your other classes going?
They're all right.
I know, no big.
A lot of work between all of them.
I know it seems. I don't know that there's much more work, but it always seems like more. I've kind of
I've
slowed down
got
a bit.
2 chemistry classes,
You got 2 chemistry classes? What chemistry classes are they?
organic and the chemistry solutions.
Okay, 2 of the hardest chemistry classes. That's you got kind of unlucky on that. That's tough. And this one, that's pretty tough. So, everybody else doing okay? Still waiting for us. See, I got Tira down there waiting to get in. Let me get her in, and hopefully, yeah, she's there now. I think. Anybody got any questions while we're waiting for people to kind of wander in this morning? Questions, anybody? As I said, we've got 2 weeks and a partial week left. This week, the end of this week is our next test, which will not cover anything that I do on systems. So anything I did Friday, anything I do today and Wednesday will not be on there. The last thing is Cauchy-Euler equations, and your homework on that is due on, I think I put it due on Wednesday. If you can get it to me early, that's great. If not, don't worry about it. That last homework set, I should have looked more carefully at the one I omitted, because it had a horrific integral in it that most people would do either online on an integrator, or they might look in tables. I mean, it had a square root in it, it had an exponential in it, it had a cosine in it. That's way beyond what you can do with parts, because with parts you need 2 things. We've never talked about what you would do with 3. So as a matter of fact, the solution, you have to leave it with the integral in it in the end. You can't finish it without an integrator. So that was totally my fault. So I omitted that. I kind of checked to see if everybody was doing the right thing. What I really wanted to see on that is if you were doing the right thing on variation of parameters, dividing through by the leading coefficient, finding the Wronskians right. Most of it looked really good. You were doing the right thing. The major errors I saw were minor errors, which were sign errors. All right, just little bitty sign errors here and there. Okay, so so that looked pretty good. This test coming up is everything we've done in chapter 4 through Cauchy-Euler equations. mostly it'll be solve problems, solve a few problems. There may be some true false or multiple choice on there, some things like that to sort of say, you know, how many elements are in a fundamental set of a second order equation or something like that. Things that were basic to what we've been doing. It will be open note. It will be open book. I will give you, get Saron in, I will give you Friday off to do it, okay? So we'll be meeting Monday and Wednesday this week. I'll get the test posted most likely by Friday. If there's, I will leave our hour and 15 minutes open on Friday if anybody has any last minute questions about the test, and then I'll post it Friday afternoon, okay? And it'll be due Monday morning by class time. So you should have plenty of time to work on that. Somehow I hit the chat button. I don't really want to chat. Okay. Questions, anybody about that? Okay. All right. So let's start looking at what we sort of go back into what we did last week and see what we were doing with systems. Let's get hooked up here while we're waiting. Okay. So this lecture, guys, is all about solving systems of equations. And we started last Friday by looking at an application. It was one of these tank problems where we had water, a brine solution going in and out of tanks and so forth and so on. And talking about how we would solve this thing. And a system of equations, let's just sort of review what we did here. We've set up a system for that thing. And we ended up with two differential equations. X1 was the salt in the tank 1, and X2 was the salt in tank 2. We wrote out what had to be true about the rate in minus the rate out. So thus we're looking at the rate of change of the salt. What we want to do ultimately is solve for X1 and X2. They'll be in terms of time. I think, let me get somebody else in here. Let's see who it is. They'll be in terms of time. And sorry guys, hang on just a second. I'm trying to get Christina in. It's not cooperating here. Let's go here. Okay, all right. So these particular functions were in terms of time. So how much salt is in the tank at any time t. So we would be solving for these two equations here, X1 and X2, which were in terms of t. We were given initial conditions that had to do with the amount of salt in the tank. The amount in tank 1 at time 0 is 25 pounds. There was pure water to begin with in tank 2. So X of 0 equals 0. So what we're going to look at today is how to solve these systems. This particular system we'll save till the end. And I'm going to let you guys look at the solution to this thing after I talk about the process. Okay, question, anybody? We did go ahead and define what we meant by a system of linear equations, two or more equations that contain derivatives of two or more unknown functions of a single independent variable t. Most of the functions you'll see in the homework are functions of t, and they call the functions usually x and y. So here's another example. Here we've got x and y are my equations, all right? Both x and y are functions of t. And we would end up with something like this. Now, one thing we said was that what we were going to do to start this process is write things in operator notation. So I'm going to scroll down to where I sort of left off and talk about how we're going to solve these things. Okay, we'll start by looking at how we write it in operator notation. Just do a little review of that. And then we'll do an example all the way through. So if we were looking at this one, and I think this is probably the last thing we did on Friday, since it's the last thing that's all marked up with red, was write this in operator notation. And when we write it in operator notation, what we want to do is group all the x things together and group all the y things together. And what's on the other side is the function of the independent variable t. But if we want to write it in operator notation, d2 means, of course, the second derivative of x. 2d1 means twice the first derivative of x, minus the function x, minus 1 times x. It almost looks like multiplication. And it's going to look a lot like that, particularly when we solve these things. But it's not multiplication. You're actually operating on something. It behaves like multiplication. But what we're going to do is we're operating on x. We're operating on x here. So when I do that, for the second one, x prime plus 4x is d plus 4x. Operator is d plus 4 on x. So first derivative of x plus 4x. And then y prime minus 2y is going to be the derivative of y, the first derivative. That's the power on the operator, is really the derivative. And then minus 2y. And on the other side are functions of t. This one is non-homogeneous. The one we're going to do first is an easier one. It's homogeneous. Over here, we're going to have zeros. It's significantly easier if you have a homogeneous one. So we're going to start out with a homogeneous one. Okay, and what I mean by that is homogeneous after you've gotten, it's equal to 0 after you've gotten all the x's and y's move over one side. So let's start with this one right here. Okay. So we want to solve the system of DEs, y prime equal 2x and x prime equal 3y. We're going to move all the x's and y's over to one side. And then we're going to write it in operator notation. Now, notice that the right-hand side is zeros. We have no t's there, okay? It's just both of these are homogeneous things. So it's a homogeneous system. So when we write it in operator notation, we get dy minus 2x and dx minus 3y. Again, that's the first derivative. dy means just y prime. All right, the next thing I'm going to do is kind of line up the x's and the y's. You're going to see something real familiar here that you're used to, and that's using elimination to solve a system of equations. So I lined up the 2x. Actually, in this one, the way I lined it up was kind of multiplying this one through by a negative right here. So that made it 2x minus dy. So in other words, I took this one, get my pen back. I took this one right here. You can multiply it through by a negative. You're not doing anything different there. You got to do the same thing to both sides. It's not going to change that 0, of course. So I wind up with dx minus y, and then the dx minus 3y is right there. So the system you're looking at looks like this, okay? X is lined up, written in operator notation, number 1. X is lined up, and Y is lined up, number 2. What we're going to do is use elimination. And this looks an awful lot like multiplication. And in a sense it is, but operators act like multiplication. If you say, I want to multiply this one by D, for example, it's just going to say, well, that's going to be 2D, which means 2 times the derivative of X, right? Or 2 times X, 2D, yeah, 2 times the derivative of X. If you multiply it by D here, that's just going to be D squared, which means the second derivative of Y. So it looks a lot like multiplication, but you've got to remember you're operating on it with a derivative. Okay, so I'm going to use a method that everybody knows, and that's elimination. There is another method here, and sometimes it's easier. It uses Cramer's rule. I'm going to talk about that possibly on Wednesday, but for today, I just want to do everything by elimination. And actually, the way your book does everything is by elimination. Okay, so what I've decided initially is I'm going to eliminate the x's right here. So I want to multiply both equations by something, one thing or the other, so that when I add those two equations together, those terms will drop out. So if you look at the x terms here, it's pretty clear if you multiply that one by d and this one by minus 2, you'll get a 2d and a minus 2d. So then you can add them together and you got those things dropping out. It's exactly like you would do, like you learned how to do in the 9th grade when you were doing systems of equations. So what I did here then is go through this one with d. You're operating on things here. So that's 2dx minus d squared x. But again, d squared just means the second to, not x, but y, d2y. And then d times 0 is 0. So you're operating on 0 as well. What's the derivative of 0? Derivative of 0 is 0. Even though it looks like multiplication, you're operating it on it with a derivative. This will be harder when these are functions because you'll have to operate on that side as well, and you'll have to take the derivative of that side, for instance, if you're multiplying through by d or operating on it with d. I'm going to multiply the second one by minus 2. That'll give me minus 2dx plus 6y equals 0. And now I look at the two equations. Something should drop out because that's the way you planned it. Right? You drop out there, you wind up with 6y minus d2y, or d squared y, equals 0. Just because it's convenient here, guys, it doesn't really make any difference. I can multiply that thing through by negative and write it sort of in the order that the derivatives occur. So second derivative there. There is no first derivative in this one, but there is the function y. Okay? So after that elimination then, what's happening is that I get this thing right here. Once things are eliminated, you get that. Now, let's remember what it means. What it means is the second derivative of y minus 6y equals 0. Well, remember we're trying to solve for y. We know how to solve that thing. This process of solving a system of equations devolves into stuff we've already done, okay? So notice that that's just a second order DE with constant coefficients. What I do, of course, is find a characteristic equation, which in this case is m squared minus 6 equals 0. All right, which means m is plus or minus root 6. Those are real roots. They're ugly, but they're definitely real roots. And so my solution looks like what it would look like if I had distinct real roots. Y equals c1 e to the root 6t and c2 e to the minus root 6t. Okay, now I'm going to do the same thing for the y's. I'm going to eliminate the y's and thus find the x's. In this one, I eliminated x's and was left to find out about y. And actually, that's going to be a piece of my solution. I found out what y is. Now I'm going to eliminate the y's. Question anybody about what I'm doing? It's pretty standard. Okay, let's look at the next piece then. So the next piece, I want to find the x's, so I'm going to eliminate the y's. Well, here was the original equation with my x's lined up and my y's lined up. If I want to eliminate the y's, I'll look at these two right here and multiply by whatever I have to in order to get those to drop out. So I multiplied that one by 3. Getting, so both of these operated on with 3, or multiplying it by 3. And the right-hand side by 3, of course, is just going to be 0. So I'll have 6x minus 3 dy. Since I was multiplying that by 3, I got minus 3d. I'm going to multiply that by minus d to get plus 3d here. That'll drop my y's out for me. So multiplying by minus d, I get minus d squared x plus 3dy equals 0. So I've set myself up right here, having multiplied by things that'll make the y's drop out. And they do indeed drop out. And I get 6 minus, from these two right here, I get 6 minus d squared x equals 0. Again, I'm going to multiply that thing through by a minus. It won't make any difference as long as you do it to both sides. That'll be d squared minus 6x equals 0. And the characteristic equation, of course, is x double, the equation is x double prime, d2 of x is x double prime minus 6x. The characteristic equation, interestingly, is the same as the other one, okay? This is not unusual, guys. It doesn't always happen, but it's typical, okay? So what that means is that my solution x is equal to this thing. Now, let's recall what y was. Y was c1 e to the root 6t plus c2 e to the minus root 6t. Okay, so right now I've got those two things right there. So I've solved for x and y, and you may think at this point that you're finished. Unfortunately, you're not, and also unfortunately, sometimes this part is the messiest part of the problem. Because we know that these two equations, if we plug them back into the original system, those two equations right there should go back into the system and give me sort of a link between C1, C2, C3, and C4. So the question is, can we find C1, C2, C3, and C4? But really the question is, can we write them in terms of fewer parameters? Okay. Now, guys, I'm gonna go back. I sort of picked up the system in a different place, in a different lecture. So let me get back to that. Take a quick break while I try to find that. Okay, there it is. Okay, let's see. Get back down to where it was. Here we go. Okay. All right. Questions, anybody so far? So far, it's just sort of things you're used to doing, like solving systems of equations by elimination. Well, there were our two solutions. C1, C2, C3, and C4 are different, but are related, so we may be able to write two in terms of the other two. And because you have a choice here, your answer could potentially not look like the answer in the book, but it is the same answer. For example, if we decided we wanted this all in terms of C1s and C2s, we'd have to write C3 in terms of those C1 and C2. And we would have to write C4 in terms of those two. We could just as easily say, well, I want C3s and C4s. Then you would want to write C1 and C2 in terms of C3 and C4. So what you decide here determines sort of whether you get the same answers. You will get, it is the same answer mathematically. It won't look the same. And you can show it's the same with a little bit of work, but it won't look the same. So here's what we do to try to get those pared down to just a couple of parameters. The original problem was that. Okay. What I'm going to do is pick one of those, and it does not matter which one. Doesn't matter which one. I chose to pick this one right here. And what I'm going to do is take what I said my solution was and plug the necessary things back into here. So in order to plug the necessary things back into here, I need y prime, which I can easily find, and I need x, which I have. A lot of times, guys, some of these things, and I'll show you one in a minute, would have a couple of derivatives in just the function, or the two functions, x and y, and one derivative. I always pick the one that has the fewest derivatives in it, because I've already got x and y here. So it's your choice of which one of these things you use. It makes no difference, but sometimes one is easier than the other. Okay, so here's what I'm going to do. I'm going to go right here, and I'm going to find y prime. So if I look at y prime here, and I've put it down here. I don't know why I squeezed it in so tight. Y prime will be C1 root 6 e to the root 6t. So I differentiated that, got to multiply by root 6, so it gets down with the C1. The C2, e to the minus root 6t and times minus root 6, so I wind up with that. So that's my y prime. So pick one of the equations in the original problem, find what you need. In this case, we needed x prime and we had x, and then proceed to plug it into one of those, all right? And we picked the first one. Okay, so here's what I'm gonna do. There's the equation, y prime minus 2x. I put in y prime, so that's y prime right there, minus 2x equals 0. So I put all of that stuff in there. Could have done it in the second one, decided to do it in the first one. It was 6 of one, half a dozen of the other here, guys, because it really didn't matter. One was no easier than the other. Once I do that, what I'm going to do is look through this thing and notice all of them either have an e to the root 6t in it or an e to the minus root 6t. And there are no terms like that over here. So we're going to play that game about matching coefficients. So this right-hand side would look like 0e root 6t plus 0e minus root 6t. I mean, their coefficients are 0 there because of that 0 on the other side. That's also what makes it easier if you have a homogeneous thing. So I'm going to gather up all the e root 6t's, which I did right here. And so that was that one. And when I multiply out, it was minus 2 times that one. So you get root 6c1 minus 2c3 times e root 6t. So in other words, those were the two coefficients, or coefficients on that. If I gather up the minus e, or minus root 6t, e minus 6, I'll say it right in a minute, e minus square root of 6t, their coefficients were minus root 6c2, that one. If I look over to this one and multiply through by the minus 2, it's minus 2c4. All right, so that's what it looks like when I gather up the terms. Now, what that says to me, because there's zeros over on the right, is that this coefficient right here, the one on e root 6t, has to be 0. And the one on minus root 6c2 minus 2c4 also has to be 0. I'm matching coefficients because of that 0 on there. Okay, that's the only way that those things can be 0. Because certainly e root 6t and e minus root 6t are never going to be 0. So what I've found here is a connection between, number one, C1 and C3. So that says that C3, if I move this over, is root 6 over 2C1. And over here, I've got a connection between C2 and C4. So if I solve for C4, moving that over here, and it'll be a plus 2C4, divide by that 2, I'll have C4 is this. Okay, we are almost finished. So when I go down, the final answer looks like this. It's y equals C1 e root 6t plus C2 e to the minus root 6t. And then I put what I've found C3 and C4 to be down here. Okay, so there's C3 in terms of C1. There's C4 in terms of C2. Now, you can see the advantage of that. And I'll talk to you about that in just a second. But questions anybody about what I did. So it's a process. Write the DE in operator notation. Work your elimination on whatever your variables are. Get your solutions using all the things we talked about in terms of homogeneous equations with constant coefficients. Get your characteristic equation, that whole business, right? And then get your solutions. And then look at them together. See if you can figure out how to write these constants, these parameters right here, in terms of just 2 of the variables, or 3, depending on how many solutions there are, or how many members of the independent, how many solutions to the characteristic equation there are. All right, so what if I had some conditions with this? What if I said I wanted to find that I arrived at the answer with the parameters, but I had conditions down here. Okay, I have conditions. I'm going to do the same thing I always do. I'm going to plug in those conditions, and they're actually set up very easily. You're going to have conditions for X and for Y. Just like in the salt tank problem, I had how much salt was in the tank, tank 1 at time 0, it was 25 pounds. And the second one was how much salt was in tank 2. At time 0, it was 0 because you had pure water in there. So you'll have conditions that talk to you about what has to be true about your system. So I'm going to plug in 0 to this one. And if I plug 0 into this one, of course, e to the 0 here, all of this is just going to be 1. So I get 5 equal, there's X right there. Sorry, I was looking at Y. I plug in 0. So that's 1. So I'll get C1 root 6 over 2. And if I plug 0 into this one, I'm going to get minus root 6 over 2 C2, and it should equal 5. Now that's not very pretty, but that's one of them. Y of 0 equal 1, I'll go up to Y, plug in 0 there, that's a nice one. C1 plus C2 has to be 1. Okay. So all I have to do now to finish up is to find out what C1 and C2 are. Guys, in this problem right here, it's ugly to solve because of these nasty looking coefficients, but it's not too hard. I started out trying to do it by substitution and saying, well, C1 is 1 minus C2 and plugging it in here. And that's okay, that works. But I also then noticed that if I pulled out the root 6 over 2, I would wind up with 5 equal root 6 over 2 times C1 minus C2. And what I saw was, oh, well, you know, if I just had that part, it would eliminate easily because the C2s would drop out. So ultimately, I just inverted and multiplied and wrote this thing divided by root 6 over 2 and got 10 over root 6, which of course can simplify. And that was C1 minus C2. And then I use the elimination on it. Okay. This thing, of course, can be simplified. Can be simplified. Well, it can't be simplified very well. It will be able to be simplified over here. But I found out what C1 was, and then I went back and plugged in and found out what C2 was. Question about what I did there, guys. If you come up with messy roots, I tried to pick some of the ones in the back of the book where the roots weren't so messy. So maybe that won't be such a big deal. The final solution then would look like this thing right here, and you would put what your C1 and C2s were. Okay. All right. So you know what your conditions are. Questions, anybody? Okay, I'm gonna try another one. Let's do another one, make sure everybody understands what's going on here. And then we may look at a non-homogeneous one, depending on how much time we've got. So let's look at another one, kind of outline the steps again. So my next one looks like this. Okay. So this is the way the problem came to me. It's kind of nice because I've got my x's, the x part of it is up front and the y parts of it are sort of at the tail end. They're kind of lined up. I'm going to write it in operator notation. Okay. The operator notation in this one, of course, is going to be dx because that's x prime. And this is y prime plus 2y, so that's going to be d plus 2y, and that's equal to 0. And this one is going to be d minus 3x minus 2y, and that's going to be 0. So I've got my system. I now know I want to eliminate. I'm gonna kind of, it's not hard here, guys. I decided to eliminate the x's first. So there's a d on this one. There's a d minus 3 on that one. I'm going to multiply this one by d minus 3 and multiply this one by minus d. So it'll give me the two terms right there with a differing sign. So operate on this with d minus 3. So I'll get So the first step, of course, is just write it in operator notation. So that's what's gonna drive your elimination. The second thing is eliminate. Take your pick. Doesn't matter. Eventually, you're gonna have to eliminate both variables, so it doesn't matter which you do first. Okay. So you saw what I did here. This times d minus 3 dot, that times minus d. When I multiply through, operating, it's a sort of it's operator multiplication is what it is. So you got d minus 3 times d, and d minus 3 times d plus 2, and d minus 3 times 0 is 0. I don't want to forget that, because when we make this non-homogeneous, I can't forget that side. I have to operate on that too. I have to take some derivatives on that. Okay, so that's what we want to make sure we do. On the bottom one, minus d times that, and minus d times that will be plus 2d equals 0. Easy enough now. The thing that I wanted to drop out was this, and it does. And what I've got left is d minus 3 times d plus 2 plus the 2d. So it was this plus the 2d, both operating on y. Okay, so that's what I wrote all that down here. Now, another interesting property of these operators is that they can be multiplied. If you took the derivative if you put this notation down there, it would say the derivative of that and then the derivative of whatever you got there, which ultimately would end up in a second derivative. If you multiply these two things, you will get the operator that does the same thing. So I just multiply this out. That's d squared minus d minus 6. And then we had the plus 2d here. And then what you see, I left out a tiny step here. If you combine the minus d and the 2d, do as much as you can here. It'll be d squared plus d minus 6 operating on y. All right, operating on y. Now what that means, of course, is y double prime plus y prime minus 6. Then I'm off to the races here, guys, because I know how to do that from what we did. I get my characteristic equation, m squared plus m minus 6. I factor it, which will be m minus 2, m plus 2. I get nice roots this time, no more root 6s. The solution looks like c1e to the 2x plus c2e to the minus 3x. So I've got one piece of this. So there's one piece. Okay. Now I need to eliminate the y's so I can figure out what x is. All right, I'm gonna go here. I would look at the original, wherever it was, up here. The original kind of looked like this. You can see what I'm gonna do. I'm probably gonna multiply this one by 2 and multiply that one by d plus 2, because that'll make those drop out. Let's see if that's what I really did. This is what I hate about not having a big whiteboard. This would stretch from end to end on the whiteboard. I don't like the up and down thing. Okay, so so I did that elimination. I did, I dropped out I got the 2 times d plus 2y and minus 2 times d plus 2y. You can sort of look at what I did there. And what I was left with was a 2d here. Those two dropped out. The y stuff dropped out. What I was left with here, see, this was an operator on x. I ended up with the same thing, d plus 2 times d minus 3x plus 2dx. Put them all together, simplify them. You'll notice, once again, you'll get this thing and the same characteristic equation. It means the roots are the same for x and y. So when I write that, I don't know why I got squished over there, but it looks like this. X equals C3 e to the 2x, e to the 2x, plus C4 e to the minus 3x. Okay. Again, on many of these, things work out differently if it's non-homogeneous. Okay, so you have to be careful. On the homogeneous ones, you are going to get the same thing for y as you got for x. Okay.
Hey, I have a question.
Yeah. Here.
Right below where you drew the line at.
Right here.
No, up further where you say now eliminate y's.
Okay. Yeah. Here.
Can you go back over how you?
Yeah, sure. Here was the original equation right here. Okay, so you're looking at that thing right there. Okay, and we're going to try to eliminate the y's. That y has a d plus 2 on it. This y has a minus 2 on it. So I want to multiply them both by something so that when I multiply it through and add the equations together, those two things will drop out. So I want them to have opposite signs here, okay? So
okay,
I'm gonna multiply that one. You see it?
The x plus 2 on the side, it made me a little confused. I thought that was like all the equation, but now I get what you said.
Oh, okay. All right. Yeah, it's 2 times this, and then d plus 2. That's a plus 2 there, guys. And I started because that's what I was saying times that. Okay. So d plus 2 and d plus 2. That's how I got that. So it gave me that. And what I do, of course, to that one, I have to do to the other one. So I got 2d there, and I got d plus 2 and d minus 3 there. Okay. You with me?
Yes, ma'am.
Okay. Anybody else got a question? Okay, so I'm down to the point where I've got a solution. So what we know is that that solution looks like that. Okay, now here comes the part where I'm going to try to get this down in terms of 2 parameters instead of 3. So we wrote it as operator notation, we did the elimination, we solved our characteristic equation and got a solution for x and y. Now I'm gonna figure out what the C1, C2, C3s, and C4s need to be. As is typical here, guys, and you can tell that you might be getting something different. I mean, some of you in the original equation might have chosen to eliminate, to get your x first. And then that would have been C1 and C2. And your y would have been C3 and C4. But again, it all washes out in the end. Whatever answer you get, if you do it right, it's going to be the same as doing it the other way. So it might not look the same, because it's different if you solve for C1 in terms of C3 than if you solve for C3 in terms of C1. But that's what we get. Okay. So the next thing I'm going to do is pick one of these equations. Look back to your original. Look back to your original system and pick one of those equations and use your solutions plugged in. So I'm going to plug this in. I'm going to plug in here to one of those. Now, this is what I was saying just a minute ago. It's easier to tell you now that I'm seeing one. I choose this one. I chose that one for a reason. You've already got the x and the y here. You'll do less work in this one because the only other thing you have to find is x prime. If you did this one, you would have had to find x prime, y prime, and then you had the y. So when you look at a few of these things, you'll be hoping you can reduce your work a little bit, okay? Because they are long and they're kind of messy. So that's why I chose that particular one in this case. It doesn't matter which one you choose. I just like to choose the one that's the easiest one to deal with. So let's see what I did. I chose this one. What had to go here when I plugged in, this thing right here was x prime. Right? And if you look at the top, I went up to this and got x prime. It'll be 2c3 e to the 2x. And this one will be minus 3c4 e to the minus 3x. So that's where I got my x prime. I needed it because that's what was in the equation there. Minus 3 times x, I just picked up my x. So that's the x right there. I just picked up my x from right here. C3 e to the 2x, C4 e to the minus 3x. And then the last thing I had to do was take minus 2 times my y. And there's my y right there. That's C1. It doesn't, that's e to the minus 3x there. Got kind of tangled up with the parenthesis. Now, so at this point, it's just, you know, it's one of those typical kinds of DE problems where it's kind of a mess, but it's a manageable mess, okay? Because what you're going to try to do is group all the e to the 2x stuff together, and then group all the e to the minus 3x stuff together. And what I did was I just multiplied everything out, so I'd make sure I got all the coefficients on these things right. And then I looked, I think I looked for the e to the 2x's. So I got that one checked. There was an e to the 2x. There was an e to the 2x. And there was an e to the 2x right there. Okay. So, and the rest of them were e to the minus 3x's. Two of these combined, if you look at these, both of these first two were C3s. So 2C3 e to the 2x is minus 3C3 e to the 2x. So I just put minus 2C3 and minus 3C3 together. Do as much simplification as you can. And so that was minus C3. So the two I put together were these two right here. And then the other one that I had was minus 2C1. Okay. So that gathering up the coefficients on the e to the 2x's look like this. The other ones that were left were the other ones that I marked. Let's see, this one, I think I marked it with a little X. This one right here with a little X. And then the last one that was left was also an e to the minus 3x. So those three, the C4s went together. So you got minus 3C4. Minus 3C4 is minus 6C4. That's how I got that. And then the other one was a minus 2C2. And that's how I got that. So you just plug it in and gathering up terms. Once you do that, match the coefficients. This side is easy to match because that's, of course, clearly just 0 e to the 2x plus 0 e to the minus 3x. Okay, so I took the coefficient on this one and set it equal to 0. I took the coefficient on that one, set it equal to 0, and now I'm in business. Because this one related C1 and C3, so that meant I could solve for C3 here. If I move the 2C1 over and multiply by a negative, there's what C3 is in terms of C1. So I can replace the C3 with that thing in terms of C1. This other one related C4 and C2. So I'm going to solve for C4. So it can be in terms of C4, C2. C4 can be in terms of C2. I divided by 2 first. I moved it over. And I got C4 is minus 1/3 C2. Okay. When I wrote the final answer, the C1, C2 were on the Y, and the C3 and the C4 on the X now became these two that were in terms of those. Now, again, you could have done this. Let me question about that one before I say what you could have done. Does everybody see what I'm doing? It's kind of a long process, but it flushes out in the end. I could have done this. I could have left that X right there in terms of C3s and C4s. So C3, e to the 2x, plus C4, e to the minus 3x. Okay. Then I would have needed to put y. I would have needed to replace C1 and C2 in terms of the C3. So for instance, this one would have been C1 would have been C3 over minus 2. So it would have been C3 over minus 2 e to the 2x. This one right here would have been C2 equal minus 3, I think. Minus 2C4. So minus, let's see, minus 3C4. So it would have been minus 3C4. Somebody get bumped out. I just heard something. Hang on, guys. Okay. So minus 3C4 e to the minus 3x. The point is, guys, you can do it with C3s and C4s, or you can do it with C1s and C2s, but you see you don't get what looks like the right answer, but you could make the connection between those two things. Okay, that's terribly written. That was a C4 right there. Okay, does everybody see what I'm saying? Okay, let's look at one more of these. Let's look at a non-homogeneous one. Questions about that one before I go away from it, or anybody need me to stay on it a little longer? Okay. So, what I want to look at is a non-homogeneous example. And what we have originally, or to begin with, is this thing right here. It's non-homogeneous because we see the independent variable over here appearing on both sides. Okay? So everybody get that one down. We're going to see what happens when we have non-homogeneous. That was like somebody's waiting to get in. Allison got bumped. Let's see if I can get her back in. Take a breather there. Okay, I think she's back in. I think. Yeah, she's back in. Allison, you're back in, I think. Okay, I see her now. Can you hear me, Allison?
Yes.
Yeah, okay, all right. Okay. I think Dr. Guzman told me your dad was trying to work at home too. That's a pretty big strain on the system.
Yeah, both my parents teach at a university, so they have class at various times. And today we all have meetings and stuff.
All right. Well, yeah. I mean, yeah. There's a lot of stuff going on. Okay, so
Yeah.
what we were doing is doing we're going to talk about how to do a non-homogeneous example. Okay. Again, it's non-homogeneous, guys, because of that t-squared right there. I'm going to write it in operator notation. So the first step is the same. So I'm going to write it in operator notation. Okay, so that's easy. This is the first derivative minus 4, so d minus 4x. This is the second derivative of y, so d2y, and it's equal to t squared this time. This will be d plus 1, so I've got the first derivative of x plus 1 times the function x. This will be dy, because it's y prime. Okay, I am going to do the same thing in this problem that I did in the other problem. I'm going to try to eliminate something here, and I think I'm going to eliminate the x's. All right, so look at the operator notation one. And let's talk about what I need to do to eliminate the x's. It's got a little messy here. My neighbors next door were having a big party. Couldn't quite figure that out. I don't think they were all related, which made me really nervous in the first place. But maybe I'm a little freakier about this than some. But I want to, I was in a hurry to finish, so I started getting messy here. So I'm going to eliminate the x's. So basically what I'm going to do is multiply this first one by d plus 1 to make it look like that, and then multiply the second one by minus d minus 4. So d plus 1 times this one right here will be d plus 1, d minus 4x, d2, d plus 1y, and I've got to multiply this thing right here on the right-hand side. It's no longer a 0, guys, but I've got to operate on it with the same thing I multiply by. So in other words, I'm operating on t squared with d plus 1. Now, what does that mean? It means the derivative of t squared plus t squared. That's what it means. You got dt squared plus 1t squared. But dt squared is 2t plus t squared. So that's why I have that on the other side now and not just t squared. Because I got to operate on that side with the same thing I, quote, operated or multiplied the other side through by. That's important on these non-homogeneous ones. Is everybody with me? Okay. The next thing I did was take the second one and multiply it by minus d minus 4. So minus d minus 4 here, minus d minus 4 here. I'm operating on 0 here, so that side remains 0. That's easy. That's nice. Okay, so pure elimination here. Okay, let's see what we're left with. The most important thing I did in that step that's different, guys, is I operated on that t squared. And I got 2t plus t squared. It's operated on that function over there was d plus 1, which is a derivative of t squared plus t squared itself. Okay, let's put all this stuff together. I got d squared times d plus 1 is d cubed plus d squared. That came from this, so d cubed plus d squared. There was a minus here, remember that I needed to drop those out, so this is going to be minus, what have I got here? Let's see, yeah, this is going to be minus d squared times d minus 4. Now that shouldn't be a square there yet. I'm just multiplying by d there, guys. That's not a, that's just the d. Okay. And I'll have d squared minus a minus here will be plus 4d. Okay. All right. So I had multiplied by d minus 4 there, and there was only a d there. That's my mistake. Yeah, there was only a d there. Okay, right there. Okay. So what I wind up with, d squared times d plus 1 is d cubed plus d squared. This one will be minus d squared plus 4d. Now, if we look at this thing right here, let's write out the dE that it's talking about. The dE that it's talking about is this thing right here. Y triple prime, the d squares go, so you wind up with y triple prime 4 times the derivative of y, so that's 4y prime, and it's equal to 2t plus t squared. So when I did the elimination on the x's, that's what I got. Now, here's where this one gets messier than the homogeneous one. You still have to solve the homogeneous part. This is exactly what we did back when we were doing either method of undetermined coefficients or variation of parameters. We were trying to figure out how to solve these things that were non-homogeneous. So there are 2 layers here. First layer, as always, was to find your characteristic equation, which was this, came from there, m cubed plus 4m. The roots of that were m equals 0 and m equal plus or minus 2i. Here we've got a YC that has one real root. So C1e to the 0t, which is just C1, of course. And then it's got this imaginary root, all right, which is 0 is the real part. So it's really e to the 0t, but e to the 0t is just 1. And it leaves me with C2 cosine 2t plus C3 sine 2t. So there's the YC for this problem. Okay. Now, good review here of undetermined coefficients or variation of parameters, whichever one you want to use. We've had 2 of them. I think in this one, let's talk about that because it's important to make a decision about that here. What we've got, let me go back down a little more. What we've got here is this thing right here. Now notice that's just a polynomial. It's just a quadratic, okay? And if you have a quadratic, you can use method of undetermined coefficients on it. I'll call it the guessing method, guys, where we make a guess. You could also use variation of parameters on it. I think probably the easiest one here is the guessing method, okay? So remember what we do. We make a guess for what the YP should look like. That's a quadratic. So my guess is going to be AT squared plus BT plus C. There's my initial guess. There's a problem with that because of that constant right there. That constant, remember, this is just 1 right here. This is just 1. So we really just get C1 there. So there's overlap between your initial guess and this thing right here. So I'm going to bump up the power on T. You'll remember this from all the homework we did with this. So that's AT cubed plus BT squared plus CT. At that point, there is no more duplication in my YP and my YC. Guys, the guessing part, as I've said all along, is the most important part here. I'm not, on your test this week, the end of this week, I only need to see you do this one time, but I do need to see if you know how to make various guesses. So what the test is going to look like in this section is I may give you one to do, and you do your whatever undetermined coefficients on that one, and then I say, okay, what if the function was over here was e to the x cosine x? Then what would your guess be? All right, what if it's this? What would your guess be? I'm just going to ask you what your final guess will be. And just because, I mean, again, I don't need to see it but one time, okay? But I need to know if you know how to make the guesses. So that's the important part. Okay, so let's go back to this one. You remember what I did here. I just found my YP. I took all its derivatives, or the derivatives that I needed. In this case, I needed 3 derivatives, the third derivative and the first derivative. Differentiated them. So I took my YP, differentiated it, and now I'm going to put my YP prime into there and my YP triple prime into there. Okay. This is one of those things you can't ever forget anything in math because it's going to come back, and it just came back. All right. So when I put that in there, and I'm going to make sort of short order of this here, guys. When I put those in there, I put in the Y triple prime, all right, which was that. Y triple prime was that. Y prime was 6A. Okay, so I did that backwards. Y triple prime was 6A. So there's the Y triple prime right there, was 6A. And the Y prime is right there. Oops, I even reminded myself and I forgot it. Okay, so I put them both in. And when I cranked out and matched all the coefficients, for instance, there was a square term here. I get one square term in this whole mess, and it was 12a t squared. So I matched the 12a with the 1 on the t squared. And I got a is 1/12. And then I matched the t's, I matched the constants. Notice the constant, there was a 4c and a 6a, just to remind you of what I'm doing. There was no constant here, so that had to equal to 0. There was a t term. When I looked at the t terms, it was only this one times the 4, so 8b was 2, coefficient on that. And I got b equal 1/4. Here's what y looks like. It looks like that. I just put everything I just found on my solution. There was that. Remember, my YP guess was a t cubed plus b t squared plus ct, and that's what I got for A, B, and C. There's Y. So you got a whole nother layer of things to deal with. All right, fortunately, the second part was equal to 0. So that one's going to be a little easier. So let me sort of make short work of this here, guys. So you got to use, since it's non-homogeneous, you got to use your variation of parameters, or maybe what we just used, undetermined coefficients. All right, next part, eliminate the y's. Real quickly here, guys, I want to eliminate the y's. So that y had a D2 on it, and that y had a D on it. I'm going to multiply this by minus D, making that minus D2 and dropping those out easily. I operated easily on this one because the right-hand side was 0, and the derivative of 0 is just 0. So when I put these two together, what happened was just that you had the first one, and then you multiplied the second one by minus D, so you got this, and that ended up dropping out. That's the way I planned it. Be careful with signs here, guys. The easiest errors to make are just those little sign errors. When I put all this together, I'll get D minus 4 from this, minus D squared plus D from that. All right. Equal the T squared. All right. T squared plus 0 is T squared. Dropping things, I ended up with this. I got a minus D squared plus 4. I multiplied through by minus. And what I end up having to solve here now, guys, is that. Just after I gathered everything up and looked at that. So getting another characteristic equations, my roots were again, well, they weren't quite the same as the other one. And this is what I was talking to you about a minute ago. The other one, when I was solving for y, had a root of 0. This does not. It's just m squared plus 4. That other one had the 0 root. This one doesn't. So the xc on this one looks a little different. It only has 2 roots, plus or minus 2i, and those are the kinds we know morph into this cosine form with all the Euler stuff we did. And then, of course, it's times, since the real part of this is 0, it's times e to the 0 t, but e to the 0 t is just 1. So there's my xc on that one. So that one was pretty easy. I still have to use my method of undetermined coefficients, because because when I added those two, I got this t squared back here, or this minus t squared when I multiplied through by minus. I need to find out what the yp is. So finishing up. And guys, I mean, you may have been writing all this down. Your book, this is an example from the book. Your book tends to skip big chunks of this, and I want you to see everything all the way through. So I kind of filled in the gaps here. But my xc looked like that. What this was a quadratic. So my initial guess was at squared plus bt plus c. Now, before I had to adjust that guess, because there was a constant in here because of that 0 root, that e to the 0 there. It's not there anymore. There is no overlap between my initial guess and this thing right here. That makes it nicer, makes it a little easier. So I'm just gonna go for it, find, there's my XP, there's my XP prime, there's my XP double prime. I will put them in back here. Okay, so X double prime is right there. X is right there. When I match all the coefficients, I get C is an 1/8. Remember, that's what's going to go on here. A is -1/4, and B is 0. My solution for X looks like this. There's the YC. There's the YP with the coefficients put back in what I just found them to be. Now, I'm almost finished, but not quite, because I really want to express this in as few parameters as possible. Okay. So what I'm going to do is take both of those things right there and put them into this equation right here. I just picked one of them, okay? Which means now I have to take this X and that Y and find X prime and Y prime, and then X, and then I have to start looking at the relationships between C1, 2, 3, 4, and 5 here. We're kind of winding up here, but what I did right here was, I wasn't sure I would get to this, and the time is kind of running out. I'm going to show you the rest of the solution, but I put the homework here, guys. I haven't given you too many of these things, and I picked them so that there were a couple of non-homogeneous, and there were a couple of homogeneous. I would try the homogeneous first. One of the homogeneous I picked was the second one. I gave you a solution there. By the way, I've put this on, I put the solution to the even ones on Moodle, okay? But so all you need to do here is write page 185, 1 and 2. This will be on there. For the non-homogeneous, 3 and 10. And I was gonna write it here, but it's kind of messy, so I put that on Moodle too. These two solutions to these even ones are on Moodle. So a couple of homogeneous, a couple of non-homogeneous. Just showing you how I finished it up though. I was pretty convinced by the time I got to there I'd be out of time, and I pretty much am. What I said is that I had to find an X prime. I had an X, I had to find a Y prime, a Y in order to plug things in. I plugged in X prime. I plugged in X, and I plugged in Y prime. Notice, guys, this is what I did want you to see. There's just a bunch of cosines and sines in here. So those are the ones I'm going to match coefficients on. And then you're looking at it and you're saying, well, what happens to all this stuff that was part of the particular solution? It will always drop out. Okay, if you think about it, if you're putting in the YPs, they're gonna drop out and give you what you had before. So you see that -1/2 t, there's the 1/2 t. You see that -1/4 t squared, there's that. You see that 1/8, there's a -1/8. So those should drop out. When they drop out, you're gonna match your sine 2t coefficients. You can look at all those, and that's what I got for the coefficients on sine 2t's. That's what I got for coefficients on cosine 2t's. What I chose to do was to write C4 and C5 in terms of C1, C2, and C3. I chose to eliminate the C4s, which if I eliminate the C4s, that'll give me 5s, 2s, and 3s. That's good. I can do 5 in terms of 2s and 3s. And then I chose to eliminate the C5s, which would have given me C3 and 4 in terms of C2. Okay, so I'll let you look at that. It's kind of messy. They don't show that at all in the book. They just say, okay, here it is. So you just got to decide what you want to do to write the 4 and the 5 with just 2s and 3s in it. There's that one. And there's that one. The 4 was that one. Okay. So you take the coefficients in one and want to write them totally in terms of the coefficients of the other. Because there were only 2, the C4 and the C5 in the second one, I chose to write these in terms of C1, C2, and C3. Okay, that was a mouthful. Guys, just try those 4 that I gave you. If you can't try 4, try 2 of them. Okay, try 1 homogeneous and 1 non-homogeneous. That'll sort of cut down on the work. You'll see if you're getting the right idea here. I will not require any homework on this until after we have the test. And I'm going to give you an alternate method, which might be in some cases a little easier on Wednesday. Anybody got a question? Let's see, who are we missing today? Haley. Haley's grandfather is sick.
So Wednesday we're doing test review.
I'll answer any questions Wednesday you have. Yes.
Okay.
Okay. And I'll outline. I'll tell you what, on Moodle before Wednesday, I'll outline the sections. There are a couple of sections we skipped, so I'll outline the sections, and I'll sort of say what's important in those sections. Okay. Mostly it's technique, but a lot of stuff is theory in that 4.1. You know, how many things are in a fundamental set? How do you show something's linearly independent? Those kind of things. Your homework will be the best guide. Okay, but I will answer any questions you have on Wednesday. Okay. All right. So good luck with everything else today, and I will see you on Wednesday.
Thank you.
You're welcome. Bye-bye.